Yeah, welcome again to the session. Yeah, people who are joining late, you can join again. So we have covered with the basic introductory parts of artificial intelligence in the previous sessions. In today's session, we will dive into the actual concepts of artificial intelligence. So as part of our syllabus, whatever we are going to cover in Unit 1, the introductory parts are basically about what is AI, why you should learn about AI, what are the challenges which you will face when you're learning AI. So what are the goals you need to meet. At the same time, you need to understand what are the different techniques available through AI and what are the applications which we have already discussed. So in today's session, we will move on to the next concepts about your AI. So the next concept in our syllabus is problem solving with respect to state space search and control strategies. So the actual concept is problem solving. So basically, because we have termed that AI will be like intelligent machines where you need to impart lot of knowledge to a machine. So if you want to make a machine understand how it need to be it need to work and all those things, you need to make it clear that we need to provide those inputs properly to a machine. So if you want to build a intelligent machine, first we need to have a proper team with a good knowledge. If you are having good knowledge on what you're going to train, then only a machine will be able to train itself. So this is all what we need to learn as part of our concepts today. So we will start with the first part, that is problem solving for today, and next we'll see what are the different techniques which we are having with respect to AI. If you want to understand a problem and if you want to solve some complex problems, what are different strategies we are having, that's what we'll be discussing in the upcoming sessions. So in today's session, as this is the first session about your in-depth concept of AI, I'll just give you an overview of what are the different problems which are already solved with respect to AI. So we will be discussing only in terms of your weak AI. As I said, in the three different types of AI, like narrow AI, strong AI, and all those things, and smart AI. So we'll be discussing only with the initial problems, that is the basic problems. Yeah. So yeah. So what is the problem? So everybody will be basically solving a lot of problems with respect to their own domains, but we need to understand technically what is a problem. Okay. With respect to AI, the term problem solving relates to analysis. So because if you want to solve any problem, you need to first understand that properly. Without a proper understanding of any question, definitely we cannot give any proper solution. So if you want to give any solution to a complex problem or any easy problem, you need to understand the procedure. That is what we call as analysis. You need to analyze it from the scratch, but like how it is being initiated, what are the necessary actions already available, so what are the necessary steps I need to take care so that I'll be having a good solution. So every time we may not have a direct solution, right? Sometimes the problem will be a complex one, you need to think a lot, you need to take some opinions of the previously available experts. So expert knowledge is very important. That's why what you call experience in particular domain makes something a better one. So without experience or without proper understanding of the problem, we cannot move forward. That's the reason initially we do some survey on what are the problem solutions already having, and how can I make something a betterment in the previous problem. That's what we call it as analysis. So if you want to solve any problem with respect to artificial intelligence, because it's a high-end area, you need to have a clear analysis of what is the problem. Then only I can move forward with my thinking. Then only I can impart some knowledge to my machine. Then only I can add some intelligence to my machine. So a proper analysis is the first step you need to make through if you want to solve any problem with respect to AI. Okay. Yeah. Next point. Problem solving may be categorized as systematic search through a range of possible actions to reach some predefined goal. Yeah. So it's very simple here. So you need to follow a systematic process. It can be a searching process. It can, because as I said, if you want to if you want to impart some knowledge to a machine, if you want to add some intelligence to a machine, you need to impart lot of things. For that, initially we need to search lot of things. We need to understand what are the protocols available. You need to understand what are the possible actions which can be taken and which cannot be taken. So because whenever you're going to write a program or whenever you're going to train an algorithm, you'll be facing a lot of errors. So the errors may be sometimes new also, which might not be easy to understand. So you need to look into all the possible actions which can be done, and then you need to set a goal, like up to what extent I can reach, and then only that will be a good way of going. Okay, yeah. So basically, problem solving methods are categorized as two types, that is special purpose method and general purpose method. So these are the two important classifications with respect to your artificial intelligence problem solving. Okay, yeah. The first one is a special purpose method, which is a tailor made for particular problem. That is, it will be confined only to some limited problems. For example, if I say I'm going to design a small application which will be answering to my questions only, it's only to my questions. It will be recognizing only my voice and it will be trying to give me answers. That is some specific one. I have trained my algorithm only till that. For example, if I say I'm going to add some intelligence to a machine which can understand only English language, if I give a question to my machine, it needs to give me an answer with respect to that. So that is what we call it as a one-on way, one-on-one. That is understanding only to some particular extents. So it often exploits very specific features of the situation in which the problem is embedded. So that means you need to clearly make it understand that this is the problem and these are the things, a set of rules which you need to follow if you want to understand my language, and the same way if you want to respond. So this is what is called as special purpose method. And next one is a general purpose method, which you can call it as a multiple way of giving some solutions. So if the previous one was only a one-on-one solution, but here the general real world problems will be able to solve with respect to this method. So it will be having wide range of applications and wide range of solutions. Yeah. So one example here with respect to general method is means end analysis, a step-by-step or incremental reduction of the difference between current state and the final goal. Yeah. So because you're talking about problem here, the problem need to be understood in two ways. That is, what is the initial state of the problem and what should be the final state of the problem. So if you're understanding that initially this might be a solution which I can give to a problem, you need to also understand what should be my final goal. Then only I can lay a path to the solution. I need to follow the set of protocols, lay some path to that, give some proper instructions. I need to move from starting stage to the end stage. So this is what we call it in general as a problem solution to a problem. What are the different ways? So basically we all know how to approach, how to define a problem and how to find some solutions with respect to your own problem. But coming to AI, it is some different phases. As you already know that if you want to solve a AI problem, you need to be good at lot of stuff, lot of areas. So you need to combine all of them in a single picture and then give a proper solution, because uh, every problem will not have a common solution, right? That's the reason you need to understand the prerequisites. What is the problem, what is the basic things I want to get, then only I can integrate all of them and lead some path to the destination. Okay, yeah. So moving on, these are some of the definitions given to a problem. So with respect to your syllabus, we'll talk about these things. A problem is defined by its elements and the relations. Yeah. So in these lectures, whatever we are going to discuss now, we will talk about mathematics. We will talk about some English, how to give some solutions. So basically, any applications what you're going to design, it can be a game, or it can be a chatbot, or it can be any web application. You need to add some intelligence to that. So with respect to that intelligence, what is that I need to add, all those things will be seen, and we will talk some technical aspects like what you can see here. A problem is defined by its elements. So what are elements and what are the relations? So you need to understand it in mathematically now. So if I draw a constructed tree or a graph, you'll be having some nodes, path. The same manner, you'll be having some relations between each problem. Okay, yeah. So we need to define a state space, that is a searching mechanism. As I said in the starting agenda, we will be talking about problem definitions. There you'll be having some state space and control strategies what we need to follow. Initially, if you want to define a problem, or if you want to define a problem statement, you need to define a state space that contains all the possible configurations. That means in n number of ways I can solve a problem. That is what you need to list out. So assume that you can take a simple example that you are doing a project. So most of you have done a micro project. So whenever you are going to team up, you will be understanding what is the problem, and you will everybody in your team will try to give your own solutions. What are the possible things I can do? The same manner, the state space here means you need to understand what are the possible things, solutions I can add to that, including some impossible ones. So whenever we are having a discussion with respect to project, many of us say that this is not possible and that is not possible. In the same manner, you need to try to include all the possibilities and also try to include whichever things are impossible also. That will be useful for the future solutions. Anybody who is trying to do betterment for your project or problem, that will be useful for them. That's why you need to everywhere, whenever you are trying to explain something new, they will ask about two things: what are the advantages and disadvantages. Advantages will be useful for your project, and disadvantages will be useful for the upcoming years who are going to solve this problem. Okay, yeah. So the first step is you need to define a state space, and next one, you need to specify one or more states that describes possible situations from which the problem solving process may start. Yeah. So because you'll be having multiple solutions to a problem, you need to start at the initial state. So you need to define what is the initial step I need to make through. Suppose if I say I'm going to design a chatbot application. So if you want to design a chatbot, it's not directly I'll go for programming, right? You'll understand what is the requirement. Suppose if I am going to design a chatbot for uh, my website, which is of something what you call shopping, it can be Amazon or Flipkart, or it is. If I want to create a chatbot for that application, you need to prepare a questionnaire with the domain. The questionnaire is very important because customer can ask n number of questions and the system need to respond it accordingly. That's the reason you need to understand initially what is the requirement. Is it programming, or is it the database required, or is it some strategies are required, some protocols are required. So you need to understand this basic thing, and then only we can think about the next phases. Yeah. So the final one, specify one or more state that would be acceptable solution to the problem. Yeah. So this is some important thing which actually student will not think about. So we will try to give solutions in our own way. We will not think about what it's already available. Yeah. So basically everybody in the world will be trying to address many problems. With respect to that, suppose if I say I am going to design a chatbot to Amazon application, so why not somebody also might be doing the same thing? So as a student or as a part of MLRIT college, I'll be doing a project for fourth year which will be useful for my project. But whenever you're going to address a challenge or whenever you're going to design something new, you need to look that in how many ways it's already available, and in who all will accept my solution. It's not only that application will be limited to my project, it should go on to the next level, and it should have some what do you call interest to the customer. Then only your project will be a super one, and that will be having some importance. So you need to understand what is the solution I am going to give, and how what is the range it is going to be accepted. Suppose if I say my application is much better than the previous one, you need to prove that, then only it will be accepted. So all the test cases whatever you are going to showcase, those all things will matter in a problem definition. So whenever you are going to define a problem definition, you need to keep in mind all these things. Yeah. From that is from initial goal to the final goal, all these are called as some goal states. Okay. Yeah. So as I said previously, we need to talk about what is the initial state and what is the final state, then only a problem will move forward. It can be elements or it can be an operators, all the basic things whatever are required, we need to impart to the knowledge base. Yeah. So here you can see the problem can be solved by using rules in combination with an appropriate control strategy. So we will talk about this thing called as control strategy in the upcoming session. So there are a lot of control strategies which we need to we need to use in our problem solution solving to move to the problem space until a path from initial to the final state. That is very important. So if you are at the initial state, you need to lay a path from how to move from initial to final stage, and what are the consequences I'll be facing if I don't have a proper solution. So every time we cannot take a risk about I will keep on going and I'll try to get a solution in a number of ways. But that's not possible with all the problems. You need to have a proper understanding. For example, you are going in general example, I'll say that if you are going to construct a building, you'll be having a plan, set of plan, like what is the structure, how many rooms I need to have. All these are the basic things which a civil engineer will look into. In the same manner, whenever you're going to design application with a software application, you need to lay down a path or a plan from what is the initial state and what is the final state, and what are the roles of each of them. Then only that can be that can happen in specified time, because everything has a time limits. You need to follow the planning, as that is very important stage. That's what we call it as a searching procedure, initial to final. What is the thing we'll do, that is what we call it as a searching procedure. That's what we call it as a state space search. Yeah. So whenever you're going to search for any problem solution, you'll be having some sequence of steps which are listed here. Search is a general mechanism that can be used when a more direct method is not known. Yeah, exactly. So whenever you are having a proper solution, obviously we will not think about the next phases, right? Suppose if I say I want to train an algorithm which will be responding to my message. If I already have a code or a ready-made thing, then definitely I'll try to go with that only. I will not look for the next possibilities. But basically, when actually we get all those problems is whenever you don't have a direct solution to a problem, we will try to gain knowledge with respect to that. Then we will be having some discussions with ourselves, looking for all the possibilities, and then only we will be moving forward. Okay. Yeah. The same manner, search provides the framework into which more direct methods of solving problems can be embedded. Yeah. Suppose if I say, as in a team of 4 members, I am a team leader, I am going to give some solution, and one of my teammate or a colleague will be trying to give a better solution than that, and third person will be trying to give his own solutions. So we need to take all this into consideration, then only the best possibility will be chosen. In the same manner, you need to design a framework with all the possibilities, and whichever the program, whichever the concept or idea which can give some solutions in the effective manner, that will be taken into consideration. Yeah. So a very large number of AI applications are formulated as such problems. Yeah. So all the AI problems, whatever you are going to do in the upcoming years, or whatever you are going to study in the upcoming years, will be basically linked to a searching mechanism. You need to understand the problem, because you are not having ready-made solutions for everything. You need to design your own way of, in your way of thinking. That's why searching is one important mechanism. What we need to go get into. Yeah. Next one is problem space. Okay. So we look into we look into the once, if I understand a problem with respect to my own application, what is that I need to move forward. So yeah, so now we will move on into some part of your mathematics, or what do you call discrete mathematics, what you learned previously. Yeah. So a problem space is represented by a directed graph. So I hope everybody know what is a directed graph, and what is a cyclic graph, and what is a tree. So yeah, that's why I said we'll move on into discrete structures. So here in the previous semester we have learned about discrete structures in your 2-1. There you have learned about what is a cyclic graph, directed cyclic graph. So yeah, so we'll try to focus on this type of things, because when you are having a problem, suppose if I say I want to move from A to D, you also have seen this in many n number of ways, like understanding the shortest searching algorithm. N number of algorithms have already been discussed by you in optimization techniques. If I want to go from A to D, if I add some weight to that, what is the cost of the matrix which I list number of path if I will be going. Suppose if I say I want to go from A to D, so I'll put some weights to each node, each path, and then I'll try to give the best solution. That is what we call it as shortest path selection. For that, we'll be using graphs. The same manner, if you want to provide some solutions to a problem, you need to lay down a graph, or you need to construct a tree in n number of possible ways, because if I go for a graph, it can be cyclic one. If a process is having some cycles, definitely we go for a graph. And if I go for tree, tree doesn't have cycles. Tree is preferred in some manners. Yeah, these are all things you have studied in data structures. Definitely you will be having I hope everybody will be having understanding of what is a tree and what is a graph. So I don't want to stress a lot of time over there. So we'll move on with our problem here. Yeah, so a problem space is represented by a directed graph where nodes represent search state. So you need to note this point. Here nodes represent a search state and path represents the operators which are applied to that state. So yeah, so when I talk about a graph, this is very important. So when I talk about any problem with respect to AI, if it is a cyclic process, we go for a graph, and you need to keep that in your mind that node is something called as a search state and path is known as your operator. Yeah. To simplify such algorithms, it is often convenient to logically and programmatically represent problem space as a tree. Yeah. So whenever you are going to apply your logical and programming abilities to your problem, you need to think it in the manner of what are the possibilities, increasing and decreasing manner. So we will take some examples and try to understand this. So in today's session, I am just briefing you what is a problem and what is that how solutions can be achieved. Yeah, in the upcoming sessions we will try to consider some examples and try to know this properly. Okay. Yeah, so this is what you need to keep in your mind about what is a graph and what is a tree, how solutions can be obtained. So you'll understand the structure like what is a node, and what are vertices, what are edges. So the basic things who you need to recall these things. Okay, so this is what is the first agenda what I want to discuss for today's session, that is what is a problem solving. So with respect to this, I would like to give you some already predefined examples. Yeah, so I'll just stop this screen share and share other slide. Just give me 1 minute. Yeah, hope everybody is now able to see a screen, a PDF file. Anyone, you can once respond in the chat box. Okay, thank you. Okay, so I'll just again take 2 more minutes to discuss about what are the different techniques AI will look into if you want to understand a problem. Artificial intelligence research during the last 3 decades has concluded that intelligence requires knowledge. Yeah, so please keep this in your mind. If you want to add some intelligence to a machine, you need to acquire a lot of knowledge, then only it's possible. So the people who are trying to develop a lot of applications with respect to your mobile phones or any applications, they are trying to design some intelligent machine with huge amount of knowledge. So to compensate overwhelming quality, so definitely if you are designing application, it should be a qualitative one. It should satisfy all the things. The knowledge possesses less desirable properties. Yeah, so what is the knowledge I need to add? What are the different challenges which I'll face if I want to develop an intelligent machine? So first thing is knowledge should be huge. It is difficult to characterize exactly, right? So every time I cannot say that I'll be getting a proper solution. Sometimes you will face some errors. Sometimes you will face some what do you call ambiguities. System might misbehave a lot of times. There will be a lot of problems we need to address. So every time we cannot expect a direct solution. It is constantly varying. That is dynamical nature of the problem. Sometimes some problems will not be having a proper solutions, and you will be need to dynamically change your code, and you need to give a proper solution. Yeah, it differs from data by being organized in a way that corresponds to its application. Yeah, so definitely depending on the application what you're going to take through, the data will be varying and the organization structure will be varying. So everything will be varying, and you need to have a proper structure. Yeah, definitely it is complicated because you need to add lot of intelligence. So whenever you are going to design an application with respect to AI, you need to keep these all things in your mind. You need to add lot of intelligence and knowledge to your machine. So these are some of the points which I have already discussed in my class now. like it can be easily modified to correct. So whenever you're going to design an application, it should suppose if I say I have launched an application and customer is facing some problems, some errors in its application, so you need to provide solutions immediately to that. You need to understand your solutions properly and reflect changes in the real conditions. Yeah, so these points are something which we need to keep in your mind whenever you are going to address a problem. It can be a real world problem, or it can be a game, or it can be any problem. You need to keep these 5 to 6 points in your mind, then only you'll be having an understanding. Yeah, so I'll be sharing this content with you and you can see. Yeah, so as I said, we'll take a small problem here, a small game. Everybody know this game whenever you have played this in childhood, called as Tic Tac Toy. This is a problem which we'll be playing, right? Some keeping X and O and trying to get some solution. So with respect to this, I'll be just sharing you a small video link. Okay, one second. Okay, I hope everybody is now able to see this on my screen. Tic Tac Toy is the one video which I want to share with you. So everybody, anybody who can respond, you can see. I hope everybody can see a YouTube link here, right? Yeah. Okay. Fine. So just for 1 minute, I'll just try to play this video so that we'll understand what is this problem. Then we'll discuss about this. I'll share this link with you also.
Hi, I'm Brett Callen, and in this video... I'm going to show you how anyone can quickly and easily create doodle videos.
Just
Hey everyone, so this
for a minute, just watch on the screen. I'll discuss about this after this video.
About my Tic Tac Toy AI. It's perfect in the sense that it finds the most optimal move for every single combination. In this video, I'm going to talk about how it works and also show you how you can get it set it up on your own computer. The source code, as always, is in the description. But before I do that, let's do a demo. The algorithm behind this is called Minimax. It's a backtracking algorithm that's used in fields like game theory and more. Minimax is used in turn-based games like tic-tac-toe or chess. To simplify things, let's consider a game where there are two players, a maximizer and a minimizer.
Yeah, I hope everybody I have just shared this video with you because you need to understand what is the game. So I know everybody of you know this game, but still just for your understanding, I have played that. So I'll share this link in the chat box. You can watch it out later on also. Yeah, so I have shared this YouTube link in your chat. So this is one important application which is a problem which has been addressed. That's why we are discussing about that now. Yeah, just give me a minute. Okay, so Tic Tac Toy is a small application which has been developed, which you can also develop with your knowledge, the basic programming what you're having. So here you will be having three rows and 3 columns, total 9 boards, what we call it as boards here. Yeah, so you need to place a value called as X or O and try to win the game. So when we are going to win a game, if you are going to get all the 3 elements in a row or column or diagonally, then only we can say our game is we are going to win, or else it will be a tie. If you're not going to win a game, it will be a tie. So if you want to design because this is a game which can be played by two people, or which can be played by computer also, right? So every time we are going to discuss about something called as chess game. Chess game is something a advanced game than Tic Tac Toy, because here you'll be having only two ways to think. Suppose if I say I have placed my position X in the first in the place of 1, the next person may keep it in the place of 5. So you need to think in the two possible ways, whether I can go for 2 or 4 or 3 or 6. So you'll be having only two chances here. So this is how you need to have knowledge. And if you want to make this understand to a system, so for our understanding, game might be very easy, just adding X and O to the next place. But assume that you are going to design this application, and if you want to develop this game, what are the different things I need to keep in my mind, and what are the different solutions I can provide. So yeah, so here you can see for this problem, if you want to develop a small game called as Tic Tac Toy, you will be having three different types of approaches. Yeah, the first approach is listed here. I'll explain about this game in the tomorrow session very clearly about what is this. So in today's session, I want to just make you understand what is the problem here. So with respect to yeah, so with respect to our discussion about today's session, you need to understand what is the problem with respect to AI. So if I say as I said, there are different types of problems which you need to address. The problem whatever I have discussed now is one problem which is being addressed. And if you want to develop such type of game, you need to impart lot of knowledge to a machine. So we will tomorrow see how it has been trained, what the structure it has been followed, whether it is following a graph structure or a tree structure. So these all things will be explained in the tomorrow session. For today, you need to keep in your mind that what is the problem and what are the different strategies I need to go through. So suppose with respect to your knowledge now, you might not be having a solution ready made in your mind. Suppose if I give you a challenge that everybody of you should design a Tic Tac Toy application in 3 or 4 days. So what you'll do, if I say it as individual project, you will just try to Google it and try to get lot of code which is already available. So because you're having a ready-made code for this, you will be able to do it soon. But assume that you are having a same type of game which you want to design, then you need to have lot of you need to go for lot of searching strategies. You need to try to understand what are different strategies, then only you can come for programming. So you need to think in this manner. You need to understand what is the problem first. You need to understand what are the different strategies already available. If nothing is available, how should I think? What are the protocols I need to follow? These all things will be in your mind. Okay. Yeah. So in the same manner, whenever somebody has developed a game application, if it is a TikTok type problem, only two steps, right? But if it is a uh, chess game, depending on the role of the coin what you're going to place, it need to think in n number of possibilities. So whenever you're going to address that, suppose if you're playing with a computer, it will be trying to defeat us. It is much more intelligent than that. In that game, it will try to defeat us. This might be your regular situation whenever you're trying to play some games with your machines. So you just need to think in the what do you call technical way, how this is being happening, what is the actual uh, progress, like what is the initial state, how they have addressed this problem, and what is the final state, how they have reached here. It's not so easy to design applications like that. You need to put your soul to that. You understand it properly because the end user might not know anything. He will just try to use your application. So in the background you need to do lot of stuff. So you need to understand the problem properly, then only you can lay some solutions. So this is what I want to explain you in the today's session. So I just don't want to go for the next topic, because I know everybody is now in just confusion, like what is sir talking actually about problem. So I'm not talking about some specific problem here. I'm talking about all the different applications what we are going to address in the future. So in the starting stages, I have said that in the initial classes that we are going to work with some projects, some higher end applications. But initially at this phase, you need to understand the basic problems. the solutions, how it has been framed, then only you can go for next level solutions. Okay, yeah. So this is the one of the topic which I have covered today, and in tomorrow's session we will try to understand what are the control strategies and what are the different problems which, as I said, TikTok toy is one application which you need to understand. So if you're understanding one process correctly, then all the process will be easy for you. So in tomorrow's class I'll explain you how the problem has been addressed about TikTok toy, and later on some puzzles. There are 8 puzzle games, 3 puzzle games, 9 puzzle games. So how a puzzle can be framed. So we will try to address the maximum possible problems which have been addressed, and we will try to gather information regarding that. Okay, so because once we are going to complete unit 1, you need to able to understand what are the different problems which I can address in the upcoming years. In the same manner, I'll be also sharing you the Python code which is available for this solution. If you want, I can just go through that and try to develop a small application for that game. That will be interesting. Okay, so tomorrow again we'll see some general problem solving mechanisms what are there apart from which are already available as part of your AI. Okay, so I just request everybody of you to once watch this video. There they have addressed how a problem has been addressed. So you'll be having many machine learning algorithms. So one of them is called as Minimax algorithm, which has been discussed in the video. That is the main algorithm which is used to address this problem. So in the same manner, for every problem you will be having n number of algorithms with your own understanding. So once you understand machine learning properly, then only this can be done. So as you are in the initial stages of your what do you call computer science, I don't expect you all to go for high end process. So you need to understand at least from these videos how this problem has been addressed, so that tomorrow when you're coming back, I'll try to discuss about the algorithm, what they are discussing over there, what are sequence of steps. We'll try to look into all of those things. Okay, so yeah, with this I just want to complete my session. So any doubts or sort of things, you can text me. Okay, yeah, so video has been shared to only one person, 596. It's now everyone. Yeah.